So in continuation with respect to previous slide, we will be discussing about the number systems in India. So number system in India, here it tells about the historical evidence, how number system came into existence in the history, how they formulated different numbers. So like in Harappan civilization, there you saw in the 2600 to 1900 BCE, where weights and measurements were found in evacuation, and Brahmi numericals were framed like earliest Indian numeral systems, later evolving into Devanagari and modern Indian numericals. So earlier there was a pebble system to count. There was no such exact measurement with which they followed. Place value system was introduced in India around the 3rd century, marking shift from simple numerical symbols to organized decimal system. So there was a numerical system, there people were not available or aware with the decimal system. So there was no exact concept defined for the system to be followed. So concept of zero is first recorded in a 9th century inscription in Gwalior, but references are found in earlier texts like Pakshali manuscript, that is 3rd to 4th century. So here, based on that, you will be able to go how the concept of zero was used. What are the salient aspects of Indian mathematics? Here it is discussed. So Indian mathematics contributed significantly in various areas. So algebra, it has been used, development of quadratic equations and their solutions, like how development of quadratic equations and their solutions was computed. So Bhaskara too worked on solving indeterminate equations for ax square plus bx plus c. So geometry, it was solved by Sulba Sutra, contained rules of constructing ultras and early forms of Pythagorean theorem. Aryabhatta introduced trigonometry functions like sine and cosine. So like this, these are the salient aspects of Indian scientists who contributed to the mathematics. So further calculus precursors were formulated by Kerala mathematicians in the 14th to 16th century. Infinite series expansion of trigonometric functions was predating Newton and Leibniz. So here combinatorics and binary numbers are framed. So here Pingala Chanda Shastra described combinational patterns and binary number representations. So astronomy and mathematics was used, like the precision astronomical calculations were made using advanced trigonometry. The concept of earth's rotations was known to Indian mathematicians before Copernicus. So further, Gupta Samkhya system. Gupta Samkhya system was a method of representing numbers using symbolic codes used in Sanskrit literature. So here objects or concepts were assigned numerical values like 4, 2 were used in the key features. So they were used in poetry, astronomy, cryptography to encode different numbers. So what are the examples of this? Ravi, Indu, Tara, like this 1, 2, 3. The Veda, Loka, Ravi means 4 Vedas, 3 worlds, 1 sun, 4, 3, 1 like this formulated. This system ensured that numbers were easy to memorize and creatively embedded in verses. How Kata system works is it's another numerical notations. Letters of the Sanskrit alphabets were assigned. How it was, the first set ka is the consonant. This is Katapaya means corresponds to digits 1 to 9. So 0 is represented by vowel or certain consonants used in encoding mathematical and astronomical information. The word Gopi Bhagya represents 31415, an approximation of pi. This system was widely used in South Indian astronomy and temple architecture.